right? So I just went over a little bit about Databricks certifications because I thought it was worthwhile to talk about because it was very valuable. So now I'm going to jump into some slides, and then I'm going to go into some code that I wrote. It's in the same link here, the bit.ly link, bit.ly/intro to PySpark. You'll be able to find the files that I'm going to be going over this deck, as well as the code that I'm going to look at. So we've covered this earlier, but not as much in the frame of mind of machine learning, which is what we're going to be going over today. So machine learning and Spark, I would say, is actually somewhat difficult. I had a hard time picking it up. There are a lot of different steps and a lot of intricacies as well. But if you're taking the certification exam, the first two slides on here are, if you know the difference between these two things and which functions are transformers and which functions are estimators on the machine learning exam, you will probably get 25% of them right. It was very much stressed on the machine learning exam. But as we've talked about before, transformers are used when you do not need to initialize a function or get information from a column before actually transforming your data. So you would see this often after a fit step, you would use a transform. You might, if you're a Python user, you might have seen something similar to this before, like after the fit step. You do not need to initialize it. And an example here is transforming a predictor column into a vector. When you take your data frame or the columns that you're going to put into your model, right before that, it actually puts all of them into a vector within one column and pipes it into your data frame. Because we don't need any information from the data frame before we run it, it's considered a transformer. This tends to be used in just pre-processing and feature generation in general. Anything that goes into a PySpark pipeline, transformers are going to be used for all the pre-processing steps. Similarly, an estimator, and I'm just going to go in here. An estimator is often what comes before a transformer. Sometimes you go straight to the transformer, but for the most part, most pre-processing steps must be initialized with data or information from an input column. So this is often used with the fit function, or estimators are. So an example of something that needs to be initialized are the min-max scalar. If you come to my machine learning class, this is going to be more code-based. The concepts are more from my machine learning class. But when you rescale your data, one way to do it is to use the min-max scalar. But in order to have it, you need to know the minimum and the maximum of a column in order to rescale your data. So that is an example of something that you need to initialize before being able to use it. So that is an example of an estimator. So anytime you're using the fit function before doing machine learning, it's an estimator. Anytime you use the transform function, it's a transformer. And that allows you to build end-to-end pipelines with pre-processing steps. There's something similar in pandas, so you may have recognized something like this before. Any questions? It'll also make some more sense when you see it. So here's an example. I'm going to go over an overview of the ones that I use for almost every single machine learning pipeline I ever make. There are other ones. They are not limited to these that I'm showing in this slide. But I want to give an overview before I go into the code and really show the entire complex process. So one of the most important transformers and estimators is the imputer function. So the imputer function imputes data from numeric values. I actually didn't realize like I've had a lot of trouble with this one in the past, I will say. It's a deficiency in Spark. So imputer functions, so we're imputing missing values. Usually you'll use the mean for numeric and maybe the mode for the categorical. They have no function that natively imputes categorical data. It's a pain in my side. So I am working on a custom transformer. I asked Databricks for some code. Unfortunately, their code doesn't work. So I'm trying to tweak it in order to actually have it work and get that mode imputation going, because not being able to put it in a pipeline is not good for deployment purposes. But for right now, it's not a capability that they have. But this replaces it with the mean, median, or mode. And then I actually did not, this was an earlier version of the slides, I did not provide that because it doesn't work, so I don't want you to go down that rabbit hole that I went down. So stay tuned, I'll have it to you soon. But you can see below, as estimators and transformers always have a very similar makeup. So they have a similar structure. They always have either input calls or input call, depending on if one column is going in or two columns. And then it always has output calls or call, depending if one or two columns are going into the next coming out of the function. So anything that you want to impute, you would put in a list here. Anything that these will stay in order, and then you can say add imputed to them. That's a best practice to have a new value coming out, so you can still look at metrics and know which ones were imputed and which ones were not. So you often see the setup of the imputer, which is the first line here, and that's setting up the imputer function. Then if it is an estimator, you will see that in whatever you set that object imputer function to, you'll see imputer.fit and have the data frame in it that you want to fit. And that will return something like a model. In this case, and it's an imputation function. And then you can take that down below to do model.transform and then put whatever data frame that you want in that, whether it's a test data frame or just the same data frame that was put through the imputer to train it. And then you'll be able to, that will return a data frame with new columns, those that you specified in the output calls, with your data imputed in them. So I'm going to be toggling between this and code throughout. Looks like we might have a question. So the question is, I followed transformers versus actions when you explained it, but I saw it in action on some of my own data this week, and the difference was incredible. So feel free to unmute and talk about what you said there if you'd like. So not good too. So I'm going to go into our code. I am not going to run this one. I'm not going to demo it today because it takes too long. So you'll see here that I did do some things to try to cut down on costs for you. If you want to run the full large data set and get a lot of practice with a real big data set, you can comment these out and not do it. If you want to not spend a lot of money on a compute cluster, I highly recommend you use the functions here, which is basically making this be about 200,000 observations instead of like 10 million. And then I subsetted the columns. Just picked some for demo purposes. There was really no rhyme or reason on which ones I chose. I wanted to subset the columns because I was sitting there and waiting for it to run for a long time. So this will help it so there's not such a wide data set that's going into our functions, and it will run more quickly. In a real life situation, we would want to do feature selection, which I show down below, but to subset it by those important features. But in this case, it was just too processing intensive for my pocketbook. So hopefully that will help you. So this is what I did, the janky thing that I did for mode imputation. As I said, I asked Databricks for a custom transformer that would allow us to put it in a pipeline. And it actually looks somewhat like what I'm showing here. So what this does, and this is, you would only use this for categorical variables that you didn't want to cast to a numeric variable, so that you could put it through your pipeline. So all this is doing a simple group by, casting it to pandas, which it might be relevant throughout the process of using machine learning. If you want to output a CSV file with results of some sort, it pulls that mode value, so the top value when I sort it by the count. And then it goes through, and for when the column is null, it replaces it with the mode value, and otherwise it keeps the column value there. So this is not a good way to do it, because it's actually replacing them in place. It's something that I need to fix and figure out a better way to do it, but that's what I got for now. So I'm going to be going over MLFlow, which is what you see here, I believe, in the next class about machine learning. I love MLFlow. It's a logging and tracking feature for models. Just ignore that for today. You may need to import the MLFlow function if you're going to run through this code. I'm not sure if I showed you guys how to do that. So I am going to go in and show you how to install a package. So here's my modeling cluster. If I click on this, if I wanted to install MLFlow, which is not, you have to do it custom for this one, you would go in and go into libraries. So this third tab over, you'll see that I have it installed. You would click install new. In this case, it's a Python function, so we'd want to click PyPy and then put the function name in there. You can see I've done all 4 of these, and then you would just click install, and it would install it for you. But back to the imputation, an example here. So the first thing that you're going to do before you even get to any of those transformers that you have, it's customary to take and pull the column names for the numeric columns and put them to an object. So what I'm doing here is going through all the field names and pulling the data type as well. And the train.datatypes is what brings the data types up. And I will keep them in this object in a list. If the data type is string and my target variable is no prior, so I'm removing that as well, because we handle target variables very different than the predictor variables. So I do the same thing for numeric columns, except in this case, we would take field, a data type, and we'd keep only those with a double in them. That's something that, if you're multitasking, stop now. All inputs to machine learning models in Databricks have to be double. They cannot be integer. They have to be of double type. So it's not just any numeric type that will work. It has to be a double. So that's one that you could go down a rabbit hole on if you didn't know that. So this pulls basically all the numeric and categorical columns. So as I said, I'm not going to run this through because it's not going to finish while we're here. But I'll show you what the output of this looks like. So I'll print the numeric calls in this case. It's going to run through. I already casted these to a double value because they're ordered categorical variables. and I wanted to be able to make sure that the order was kept right, with the lowest education at the bottom and the highest education at the top. Same with the first use and frequency. Those are the age that you first used a drug in this case, and the frequency in which you used it. And if you look at the numeric calls, the categorical, we're going to see a small subset of the features that are in this data set. So that's what you start off with. Then it is customary to not overwrite your variables that you have in your original model. So like at the end, you can find summary statistics and things like that without all the pre-processing to be included. Since we're talking about imputation, I'll pull this one up as well and show what the output of this looks like. So what I'm doing here is taking my numeric column names, and then I am creating a new list of column names with underscore imputed on them, so that I will be able to identify which data was imputed and which data was not imputed. So that is the customary way to set up your data. And then the part that we've already talked about. We would have our input, which is numeric columns, and for our imputer. And then our output columns would be the number of the num imputed calls, which is up here. So those ones that have underscore imputed on them. And in this case, we do have one more value that we want to put in. I believe the default strategy for imputation is mean. So your choices here are mode, median, and mean. So you'll want to specify what you wanted to do in this case. So the reason I chose mode in this case, even though it's numeric, is because remember, it's a ordered categorical variable. So we wouldn't want to find the mean of a categorical variable. So I went with the mode in this case. Are there any questions on that first imputer value or how to get it in, anything of that sort? Right? So now I'm going to go over, you see here, all the other ones look very similar, and usually you will do this in an order, and the output of one will be the input of another. So the first one that we run is the string indexer. So that's our categorical columns. This outputs the index output columns. And you can see that the index output columns is the input into my next step in my pipeline. So I'm going to jump back here. Since there are no questions, I'm going to go on to StringIndexer. So StringIndexer is what you use for categorical columns to put them into, if you have strings for your categories, to make them numeric in a way that the model can handle. So the StringIndexer in this case will take your categories. You can see kind of a screenshot. This is from Databricks' website. So say you have a category of ABC. When you input it into a categorical variable, it will then make it to the strict category index. So it will take that and cast it to a 0, 1, and 2. So that is something that you will need in order to do any hot encoding or anything like that. You're going to have to do this first before putting it into any of those other pre-processing functions. So one interesting thing is they do make it very easy for you. So it stores all of the string names for our category indexes, so that you can use index to string to actually get those names back after you've gotten your final model that has been trained. So this is really helpful. And you'll see again that it looks very similar to what we've seen before. So we have the indexer, we have our input call, and then we have category going in. So whatever our input column, notice that since there's only one column going in, there's no S on input call. you will have then the output call with a category index, which is shown here. So that's usually step 2, unless you use one of the more specialized functions that are not as common. And the next one I want to show you is the one-hot encoding. So a lot of you, hopefully you've learned some about machine learning, that you have to do dummy coding in order to use machine learning, making those variables with more than one category. You would have a column for each one and if that value was present, it would be a 1. And if the value wasn't present, it would be 0 in those cases. So this is used for unordered categorical variables only. You do not do it with ordered categorical variables. But that's what the one-hot encoding function, one-hot encoder, does for you. This is also a estimator, not a transformer, because you have to have that input from the previous column. So in this case, it will take a, say, 5 category variable, and the value 2, for instance, will be encoded in Spark as 0, 0, 1, 0. And remember, indexing starts at 0 in Python, so that will help you understand why value 2 would be a 1. So that is where the one-hot encoder would be used. You're going to see very similar syntax. We have our input call, output call, or calls, depending on how many you have. And then you would actually use a fit method and then a transform. And finally, the last step before you can actually put something into a model is the VectorIndexer. So that takes all of your columns that you specify that you want to go in your model, and it takes all of your features and it puts them into one column. So the input columns will be column 1, column 2, for example, and then it will output what we call a sparse vector with your features. So your model isn't going in as a data frame, the data is going in as a vector. So that's what the vector assembler does. A sparse vector means that all the zeros are removed from the vector so that the only things that are stored are anything other than 0. So if there's a 1, if there's a 2, it will store that value and just store the placeholder where the 0 would go. And that helps Spark without not so much data, and it will help speed up the processing of that data frame. It's one of the Spark things that you'll learn. Another thing, it does identify categorical versus numeric variables. The default max categories is 6. So if you have anything with more categories than 6, it's going to assume that it is a numeric and change it to a double. If it has less than 6, it will assume it's a categorical. And this is a value that you can set if you want and adjust if need be by your use case. This VectorIndexer is not an estimator, it's a transformer, because we don't need to initialize it or have input from the columns to actually run it. Okay, so lastly, there are some other useful estimators. In this case, I did not use these in our example code. I did try PCA, it didn't help in this case, so it was not included in my example code. PCA runs principal component analysis on columns. If you don't know what that means, it's a pretty important concept in machine learning. I would highly recommend looking it up. It's a thing that you would do in particular where you find it useful before going into unsupervised models, even more than supervised models, because k-means it needs this if you ever used like the clustering techniques. You also will need to scale your continuous variables, which I don't have any in this data set, which is why I'm not showing this. You can do that through min-max scaler or standard scaler. Another thing that's common is to bucketize your columns. So if you have a numeric column and it's not predicting well, putting it into buckets of like 3, 5, 10, whatever have you, to try to break down that noise. So you'd want to use that if you have really noisy data in a lot of cases. And you can also do a custom SQL transformer if you want. And like I said, I'm trying to do a mode imputation estimator that I'm trying to build. Partly it's Databricks and partly myself, but that would be an example of creating a custom transformer that Databricks doesn't have or PySpark doesn't have. So now just coming back in, we have our StringIndexer. We've already talked about that. Our one hot encoder, our numeric imputer. Everything goes through a vector assembler, whether it is numeric or categorical. So you'll see the last step of my my categorical inputs. Those columns were actually moved down in here into an assembler inputs column object. And I also took my numeric imputed, which was my last numeric step, made sure all of those were in that inputs, and then put them into the input calls. You'll notice we have S here because we have multiple columns coming in, but notice here we have call. So it takes all of these inputs and makes it a vector that goes in one column, and that's what this does for your data. And then you'll see the model itself obviously would be an estimator as well. So that's what is shown here. I give a couple examples. I show a logistic regression. So in this case, it's a lasso regression. I show a random forest in this demo, and I show a gradient boosted trees. But they all look similar. The label column is, in this case, no prior. So what we're trying to predict. Our features column comes from the vector assembler. It always comes from the vector assembler. And then elastic net param is a hyperparameter that I inputted into my model to try to adjust it. That means that it's a lasso regression, not just a normal logistic regression. So that is the final piece that you need. Is there any questions about this? We'll get to the pipeline part in a minute. All right. So just as another example, I'll come down here. I can reuse all of those, the vector assembler, everything. All of those look the same coming into the random forest model because I have the same features coming in. If you change your features, you're going to have to adjust that. So this is an example of a random forest classifier. This might actually be, this one ran more quickly than the logistic regression. So I might go ahead and actually, I think I have to run the one on top first. So we have, again, our label column and our features column that came out of the vector assembler. All right, so if there's no questions, I'm going to explain this part. Go back to the slides for a second. So I'm assuming this probably has to sink in. It's a lot. So if you are able, Databricks does a fabulous training, scalable machine learning training. If there's any way to get your company to pay for that, or if you're interested in it, is excellent. I would highly recommend doing that if you can. It goes over all this, has the best demo code you've ever seen, and I've used it throughout my time as a data scientist to build a lot of what you're seeing here. So you're probably like, man, that's a lot. So especially if you have to do a fit and a transform function, and we saw in the previous slides. we have to do this for each one and have an input and an output. That's a lot of code. Like, that's overwhelming, and there's a lot of ways to screw up. So in order to do this and make it much more easy to deploy in production, it's best practice to put all of your pre-processing steps in your model into a pipeline. This part's actually pretty simple. Once the setup is the hard part, getting the right columns to go through and go through the right pre-processing tool. But you'll see here, I have all my different steps in a list, set them to steps, and then all I do is create a pipeline. We put stages equals and puts these values in it, and then we can fit that with our training data. And then we can use that to predict on our test data, and then we don't have to run these pre-processing steps again for our test data in order to replicate that process. So it's really useful from that perspective too, or you'd have to rewrite this both for your test and holdout data set. Coming back, go ahead.
What package does that pipeline command come from?
It's inherent in Databricks. So any PySpark IDE you use will have that already pre-installed.
Okay, so it's PySpark?
Yes. So you'll notice here, you do have to take and like load all of these. I did do them one by one just so you could see. I did it above the code where I used it so that you would be able to kind of see what's there and what packages they're in. You have to import them, but you don't have to install them, is the difference. All right. So that pipeline is created here. This is great. So one thing that didn't used to exist in Databricks, which it does now, is real-time, real-time deployment. I've never used a real-time one in my career so far. But you can actually deploy this, so prediction data can come in and hit this in real time. If you have any use cases for that, Databricks is best for batch processing. So if you're doing like having it come in and having large batches of processing, so that's what it's better for, since you have to scale up the cluster and scale down. So for real time, it can get expensive for clients. So that's what we do here. You'll notice here that I am fitting my pipeline. So we talked about that. And then I'm actually predicting on my test data with the transform method. So that's what you use transform for, is to actually predict on your data set here. Are there any questions about the pipeline? All right. So one of the, a big gripe that I have, that you'll find that just Spark is newer. So sometimes it doesn't have things at all, which the mode imputer is an example, or they won't have converted some of the models from RDDs, what was brought up at the beginning of this call, to data frames yet. That is the only use case I've ever needed to use an RDD, was when I needed to use a model that was in RDD but hadn't been piped over to data frames yet. So yeah, so when one of my gripes is that often in Python, you'll use grid searches, so you don't have to code this out one by one. It's a pain in the butt, so you wouldn't want to copy and paste your code and do it over and over again. Grid searches only output two metrics, and they're two metrics that I don't use very often: the ROC curve or the precision recall curve. So the area under it. They're definitely not the most common model evaluation metrics to use. So I always end up going through and doing it by hand, unfortunately. So there is no function for calculating accuracy, precision, recall, and F-score. That shocked me when I found that out. But so I do that In this case, I find the true negatives, true positives, false negatives, false positives. I also go through and then I use those to get accuracy, precision, recall, and then use these to get an F score. And what I'll show next week is how to log those with MLFlow, which is what's shown here. And the process of getting, in this case, coefficients, you're going to see feature importances farther down from the random forest and the gradient boosted trees. So a really good thing about pipelines is you can actually pull out one of the parts of your pipeline with indexing. So in this case, I want to get the last value, LR, in order to get my coefficients. So in order to do that, I take my pipeline dot stages and we do -1 to get that last value. And that sets it to the LR model. So it extracts just the model from our pipeline. Then we have this janky code over here that shows how to get those coefficients into a pandas data frame. So I'm not going to go over this. It's out of scope to go over how to code in pandas. But what this does is creates this. You can see in this display down here, my coefficient is my first column. So I have them sorted from top to bottom. And then I have my feature here. So the highest the value that increases, say, the probability of you be relapsing and ending up back in substance abuse admissions, which is what we're trying to predict here, is using cocaine or heroin. Those are probably don't surprise any of us. And you can see them go down from there. At the bottom part, so the frequency, it is showing that the lower the frequency, we're seeing like an indirect relationship there. So that's actually I would actually go back and look at this one because that doesn't seem right to me. So that's the process that you would go through when running these machine learning models. So theoretically, as the frequency of use goes up, so should the probability of substance abuse relapse. And that's not what's showing there, which makes me think there's something wrong with the feature itself. So that's something I would actually check into. Services is basically where they put in inpatient or outpatient, things like that. And then I went and I just printed out my accuracy metrics. Keep in mind, this is 2.5% of our data set and a very small subset of features. So it's not that we're chosen pretty much randomly. So this is not going to perform well. So accuracy was only 69%. Precision was 70. Recall was 83. And the F score was 76. So if you want to know more about these, my machine learning class will be really good for that. We're seeing down here something very similar. We have our random forest steps, our random forest pipeline goes through all those steps I just went over. This is a bit different because instead of pulling coefficients, we're pulling feature importances from the random forest itself. So that's what's shown here. We're seeing the most important feature is that frequency, the one that I needed to check on, the service setting, being employed or not, and it goes down from there. So that is how to run a single model at once. Are there any questions? All right. So the last thing I want to go over is how to do a grid search. Grid searches allow you to perform multiple models, and it's actually a lot more processing efficient because it can run multiple models at the same time because, as you know, Spark is parallelized. So if you have a large enough cluster, it will actually be able to run multiple models at once and finish them quicker. And then it also allows you to not have to code out each of those models individually, one by one, and to sweep over a bunch of features, a bunch of hyperparameters, and you can even do feature tuning with this. You can sweep through them with this grid search. You have to do a couple of steps additional for these. You have to set up a binary classification evaluator. So that tells them what my raw prediction column is, which it's by default, Spark sets it to be prediction. Our label column, which is no prior. And then the metric name, which is area under ROC. The only other choice is area under the PR, so precision recall curve. That's why I don't use grid search very often. You can't pull feature importances. You can't pull area accuracy, recall, any of that for each individual model. So it might be good for honing down which one's the best, but to get all that information, you have to run them individually, which is one of the gripes I have. You also need to use either a train validation split or a cross validator. Train validation split's going to be much faster because it only runs one model. Cross validator will run multiple models, but again, it does it in parallel. So it depends what your budget is. And then that finally goes down. You take your pipeline. That is actually put in here in our estimator. We tell it the train ratio we want. So I want 70% of my training data to be training and 30% to be validation. I specify in here the grid that I'm going to search through with the estimator param maps. That's this. And then I put in here the evaluator as well. So how to evaluate those models. So it tells it to use area under the ROC curve. And finally, we take that training data, we fit it, and then we transform with our test data, just like we've seen before. But this is going to run more than one model at a time. So something I'm going to give you actually, before I go on, do you have any questions about grid search? Okay, so while we have a couple minutes left, I'm going to show you guys real quick a teaser for next week. Is MLFlow. MLFlow is a great way to deploy models. I love it because I can easily track models. So one of the things you'll see as a data scientist, you throw things against the wall, see if it sticks, try something else. What I find without MLFlow, I end up running multiple models, like the same model multiple times, because I'll try something, I'll think it didn't work, try something else, and then I'll say, okay, that old one was actually better, and then I'll have to go back. So without MLFlow, the only way to not have that happen is to copy and paste your code over and over, or make a user-defined function, which wouldn't really work in this use case. So MLFlow allows you to track those and reproduce runs as well. And that's what all these logging statements that you're seeing are. So you can see the last model that I ran. I'm going to open it up. And we'll go over this more next week. It's just a little bit of a teaser. You can use this with Python or R on your local computer as well. So that's also really relevant to this. Our logistic regression, we used elastic net param. So I put my hyperparameter in here. I logged my accuracy, F-score, precision, and recall. I also logged my coefficients. So this is in a CSV file that I could download here. It also outputted my model as a Spark file, so a model that can be deployed. And if I wanted to deploy it and make predictions on it, all I would have to do is literally copy this code and then feed data into it. You can do it with a Pandas data frame and with a Spark data frame with this existing one by copying and pasting this in. You can register it so that you can have it and it's easier to deploy. And then this is really saved me a couple of times. You can click reproduce run. So what that'll do, when you run multiple Spark models on different cluster configurations, you're going to get different answers. If you run your code in a different order, you are going to get different answers, because as we know already, the data is partitioned on different partitions. So even if you set the seed, if your data is partitioned differently, it will give you a different answer than the one prior. So what this allows you to do is build up a cluster that has the same configuration as the one you trained your model on, makes it identical so that you can go through and run and get identical results, which is really cool. And you can do this even for grid searches. It's the best way to track the results of grid searches. So you see here, it ran 4 models and it logged each one of them. So I can say, open it up, see the grid search all in one place, and I'll be able to just deploy this model if I wanted. So in this case, we have our max depth estimator, all of this. Only problem is all I see is area under the rock curves. So it's a bit difficult to use if you want to use precision and recall or F-score, which is what I usually run. And then it'll also tag it for you. But this is next week's class. And then this is also a good deployment platform as well, if you want to deploy something elsewhere. And you can use it locally with R and Python. So if you like it, you can actually transfer it to any work that you do with machine learning modeling. Any questions? Either about Spark in general, feel free, Spark in general, Spark with machine learning. We have a couple minutes, so I'm happy to answer any questions, or even data science. Feel free to ask away.
If nobody else is going to ask a question, just as a confidence check, did we change data sets this week, or am I getting confused between your 2 classes?
Yes, it's the same one as the machine learning class because I had it built out. So we did. I probably should have gone back and explained that, but then I was thinking that this was the machine learning class, so my memory was not serving me.
I understand, because I was having the same problem. I've been trying to figure it out the whole class. I was like, I know this data set, but this isn't what I had already saved.
Yes. So it's something I had pre-built. It's my pet project. So here, that was totally my bad. Thank you for bringing that up. The data we're using has every admissions to a substance abuse treatment center that is publicly funded by the government. What we're trying to predict is the first-time admissions versus the repeat admissions. And then the goal will be to predict which individuals are at high risk for relapse upon admission to a substance abuse treatment facility, so that they could find those high-risk patients earlier, theoretically, when someone would come in. So this gives a link to it as well, but that's also uploaded on my OneDrive. Thank you for pointing that out.
And to use the code at the beginning of your notebook, we would have to download the CSVs and upload them to the storage, right?
Yes. So the Azure storage, if you guys weren't, I know a lot of the different people that weren't there in the beginning, I do have a step-by-step walkthrough slides in my OneDrive that show you how to set up Azure storage. And you can
but
also,
we can't leverage yours. We'd have to upload it ourselves, right? Okay.
Yes, into your own storage, but those slides do go through how to create one of your own. And then this is the code to read it in, actually. You are not going to be able to upload it directly into Databricks because it's going to tell you, hey, that's too big. Sorry, can't do it. So there's a row limit on uploads directly to Databricks.
Okay, thanks.
Any other questions? All right. So feel free. I haven't actually shared my email, I don't think. If you guys ever have any questions or you have a bug that you can't figure out, I've seen most of them. I can probably help with any of those problems. I do it with the people I work with. I'm teaching them how to use Spark right now, actually. So feel free to shoot me an email if you ever need. I've just put it in the chat. Thank you, everybody. Appreciate your time.
Thanks, Kelsey.